Throughout education, from the first day to the last day, there should be a sense of intellectual adventure. The world is full of puzzling things which can be understood with sufficient effort. The sense of understanding what had been puzzling is exhilarating and delightful. Every good teacher should be able to give that. I will try to do that. I remember my happiness when I first read Newton's deduction of Kepler's law from Newton's law of gravitation. Few joys are so pure and useful as this. Initiative and individual work will give the students the opportunity of discovery, and this give the students sense of mental adventure far more often and more keenly than is possible where everything is taught in the class. Let the students be active rather than passive. This is one of the secrets of making education a happiness rather than a torment. Physics developed because of the curiosity of people to understand the universe in which they live. Electricity was one of the branches of physics, magnetism another branch. Due to the work of Ampere and Hans Christian Ørsted, we could understand the relation between these two fields, electricity and magnetism. The result is the development of a new branch known as electromagnetism. Gravitational force, tension, frictional force, normal force. Newton treated all these forces as separate forces, but we now know all these forces are electrical in nature. For example, when we push a body kept on this surface, there is a frictional force. That frictional force is due to the interaction of the atoms in the late 19th century and the beginning of the 20th century. Due to the works of Rutherford and J.J. Thomson, we could understand that atom is electrically neutral. Atom is made up of nucleus at the center and it is positively charged. Electrons are outside in an orbit. So number of protons will be equal to the number of electrons in a neutral atom. When there is an interaction between the atoms, there will be force of attraction or repulsion depending upon the distance between the atoms. For the convenience of study, electricity can be divided into two branches, electrostatics and current electricity. In electrostatics, we will be learning properties of the charges when they are at rest. Current electricity, we will deal with charges when they are in motion. According to Newton's gravitational law, force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between the charges. In electrostatics, we will be dealing with charges. First, let us see how charge was discovered. Around 2000 years ago, a Greek philosopher, Thales, found that when amber is rubbed with fur, it attracted bits of paper. If a paper bits are kept nearby, it is attracted by this amber. At that time, they did not know the reason. In 18th century, another scientist, William Gilbert, found that not only amber rubbed with fur, glass rod rubbed with silk also showed the same property. When glass rod rubbed with silk, it is attracting bits of paper. Actually, what is happening is when glass rod is rubbed with the silk, some of the electrons from the glass rod will be going to silk, is transferred. So there is a transference of charges from glass rod to silk. One experiment was conducted. A glass rod rubbed with the silk is suspended using a thread, so it will have positive charge. Another glass rod rubbed with the silk is brought nearby. This glass rod also positively charged. They found that there is a repulsion between these two glass rods. From this, they understood like charges repel. Next, they brought a ebonite rod rubbed with fur, so it will have negative charge. They found that there is an attraction. From this it's clear, unlike charges attract. Force of repulsion or attraction between two charges is given by Coulomb's inverse square law. Then we'll see some of the properties of charges. Law of conservation of charges. So you are familiar with law of conservation of energy. Energy can neither be created nor be destroyed. Similarly, in electrostatics, there is law of conservation of charges. When you rub glass rod with silk, electrons are transferred. There is only transference of electrons. According to law of conservation of charges, charges can neither be created nor be destroyed. The next property is quantization of charges. One electron can go, or two electron can go, or three electron can go. Robert Millikan determined the charge on a single electron by an experiment. As per that, charge on an electron is given by this 1.602 into 10 raised to minus 19 Coulomb. One electron can go, or two electron can go, or three electron can go. So charge on a body will be multiples of a minimum amount. That is a charge carried by a single electron. So charge on a particular body will be multiples of the minimum. That is a charge carried by an electron. So mathematically we can write Q is equal to N times E. Benjamin Franklin argued that when we are rubbing, charges are transferred. Before rubbing, both the bodies were electrically neutral. From this is clear there is only transference of electrons from one body to another body. This naming positive charges and negative charges was given by Benjamin Franklin. Physics problem solving ability is very, very important. So then and there, let us do problems wherever possible. This is a quantization of charges. Mathematically we can write like that, Q is equal to N times E. Charge on a body will be multiples of the charge carried by a single electron. Now let us see a problem based on this expression. Now we will see a problem based on quantization of charges. So you are asked to find out the number of electrons in 1 coulomb of negative charge. To make the idea clear, if the glass rod is rubbed with the silk, electrons will be transferred from glass rod to silk. So question is to find out how many electron is needed to make 1 coulomb. So that is based on quantization of charges. Mathematically, quantization of charges can be written as Q is equal to N times E. We know the charge on a single electron. In this question, we have to find out the number of electrons needed to make the charge 1 coulomb. After rearranging this, N is equal to Q divided by E. Q is 1 coulomb. Charge on an electron is 1.602 into 10 raised to minus 19. This 10 raised to minus 19 taken up, it will become 10 raised to plus 19 divided by 1.602. After doing this calculation, it will be 6.25 into 10 raised to 18.